Now let us consider the second part of the second experiment. So in this we will be studying the transfer and drain characteristic of a JFET. So earlier we studied the transfer characteristic of a MOSFET. Earlier, earlier we studied the transfer characteristic of a MOSFET, and now we will be trying to find the transfer and drain characteristic of a JFET. So in the MOSFET there were three terminals: gate, drain and source. Similarly in the JFET also we'll be having three terminals: gate, drain and source. So in the MOSFET you are applying some positive gate voltage, and whenever a particular voltage is reached, okay, at that particular voltage your MOSFET was turned on. Whereas in case of JFET, what happens is at 0 volt itself, okay, at 0 volt itself your JFET would be conducting, or it will be turned on. In order to turn off this JFET, what we need to do is we need to provide some negative voltage. If we provide negative voltage, then this JFET will be turned off. So that is the major difference between the MOSFET and JFET. So in case of MOSFET, we will be applying the positive voltage to turn on the MOSFET. In case of JFET, it would be turned on at 0 volt itself. We will be applying the negative voltage to turn off the MOSFET. You just observe over here. So this is your gate terminal. For the gate terminal, we are giving the negative supply, and for the ground we are giving the, just look over here. So this is your gate terminal, so this is your drain, and this is your source. For gate terminal we are giving the negative supply and positive supply is given to the ground. So what does it indicate? So this is reversed biased. Whereas in case of MOSFET, if we observe MOSFET, so in the MOSFET, just look over here. In case of MOSFET, so this is your gate and this is your drain and this is the source. For the gate we provided positive, for the ground we are given negative. So this was forward biased. Whereas in case of JFET, so this is reverse biased. So this is the major difference between the JFET and the MOSFET. So the aim of this project is to plot the transfer and drain characteristic of the JFET, and the apparatus what we require is JFET. I will be making use of the JFET name BFW 10. So this is the JFET which we will be using. So you can look over here. This is the JFET which we will be using. Along with that, we require two resistors. One is of 1 kilo ohm and the other resistor is 100 kilo ohm. So we require two resistors. One should be of 1 kilo ohm and the other resistor of 100 kilo ohm. Okay, so we will be making of two resistors. And the other resistor of 100 kilo ohms. Then we require ammeter to measure the current, and we require voltmeter to measure the voltage. And this is the circuit diagram. The major difference is, so here the gate and source is reverse biased, and drain and source is forward biased. So this is regarding the circuit diagram. Next, when we come to background theory, as I explained earlier, in case of JFET, the gate terminal should be reverse biased in order to turn off the JFET. It starts conducting at 0 volt itself. Okay, in order to turn off, we need to provide external negative supply. Let us look at that by animation. So this is your drain and this is your source. If you look over here, So this is your drain, okay, and this is your source, drain and source, and this is your gate terminal, and this is your gate terminal. If we apply a negative voltage between gate and a source, so this will be turned off. At 0 volts it starts conducting. So here we will be giving some voltage VDS, okay. Let us give some voltage between drain and source, and you just look over here, between gate and source the voltage is 0, and between drain and source the voltage is 0. Let us increase the voltage to 5 volt. So it is conducting, okay, right. The current is flowing here, okay, between drain and source, because the gate voltage is 0. If we give negative voltage 0, minus 0.5, minus 1, minus 1.5, minus 1, 2, if we go on increasing the voltage, that is negative voltage, so just look over here at 0 voltage, so this is the current, it is conducting. So if we go on increasing the negative voltage, see the current conduction is decreasing, because the channel is getting reduced, okay, the channel width is reduced. So just look over here, the current is decreasing. So a higher current was at this 0 location, and it is going on decreasing as you increase the VGS. When it reaches minus 2.5, it is completely stopped, so your JFET is off. So what does it indicate is, whenever the VGS is at 0 volt, the channel will be open and the JFET would be in on state. When we go on giving the negative voltage, okay, when we go on increasing the negative voltage, so the JFET gets turned off. So it is getting turned off at minus 2.5 volts. So this is regarding the JFET, okay. Now we will be studying the characteristics of this JFET. We will be studying the characteristics of this JFET using two characteristics. One is the transfer characteristic and the other is the drain or output characteristic. So let us study this one by one. So first let us study the drain characteristics or the output characteristic. In order to do that, first we need to rig up the circuit. So let us rig up the circuit using the multi. Now let us first find out the drain or output characteristic. In order to find out this characteristic, we need to rig up the circuit. So the circuit diagram is shown over here. So we need to construct this circuit diagram in the multisim software. So let us open this multisim software. So the first thing what we require is the JFET, and the name of the JFET is BFW10. So this belongs to the transistor family. So we'll go to the place transistor, click on place transistor. In the transistor group, you select the JFET, and it should be of N type, okay, JFET of N type. So in the component window, let us BF W10. So this is the name of the JFET. So click on OK. So your JFET is placed in the window. Next, what we require is resistor. We require two resistor of 1 kilo ohms and 100 kilo ohms. So click on place basic. In that, select a resistor and select 1 kilo ohm and click on OK. So 1 kilo ohm resistor is being right. So you select this, Control C to copy that resistor, then Control V to paste the resistor. So the value of one resistor is 1 kilo ohm and the other resistor is 100 kilo ohm. So let us make this 100 kilo ohm by double clicking on this and change the value to 100k and click on OK. Now your JFET and two resistors are being placed. Now we require two power sources. We go to place source, click on that, select power sources. Within the DC power source, click on OK and place the power source. Again we require another power source, click on the power source and click OK. Now we need to take one ground terminal, since it's a power source we are using, so take one ground terminal, then close this. Now all the components are available. Now we require meters. We require two voltmeters and one ammeter. So go to place indicator and pick one voltmeter vertical and place it at this location. Again select another voltmeter vertical and place this at this location. Then select the ammeter horizontal and place at this location. Now all the components are available. Now we need to join them. So we just need to join them. So now joining the drain to resistor. So you just flip horizontal so that positive could be joined to the positive of the battery. And connect these two. Next, here 100 kilo ohm resistor should be given to the gate terminal. Now you observe here, this should be reverse biased. So flip vertical. So this is your negative terminal and this is the positive terminal. Negative terminal will be given to the gate and your positive terminal should be given to the ground. So this is a major difference between MOSFET and JFET. Now you connect this source to the ground and connect this negative to the ground. Now this is your voltmeter and connect this voltmeter and again you connect this voltmeter. Now the circuit is ready. Now we need to name the terminals. Okay, so you know that this is your gate terminal and this is your drain terminal and this is the source terminal. The voltage between gate and source can be named as what? VGS. So we'll be naming this as VGS. Next, the voltage between drain and source can be named as VDS. It can be named as VDS. And the current which is entering into the drain, okay, so we can call this as what? ID. So we'll be naming this as ID. Now let us make the changes. Let us name this as VGS and click on display. Uncheck this one, check only show labels and click on OK. So this is your VGS. Now we need to name this as VDS. Label VDS, then display. Uncheck this one, check only show labels and uncheck all the attributes. Click. This is your VDS and now this is your ID. So wait, current ID, display, uncheck. So except show labels, everything should be unchecked. Click on OK. So this is your current ID. So now you label the all the required things. Okay, now look over here. So this will be named as VGG because this is feeding the gate terminal, and the other source is feeding the drain, so this will be named as VDD. Okay, so let us name this as VGG. Let's name this as VGG, and here only in case of source we need to check show labels and show value. Okay, next here it is VDD, label is VDD, and display. Okay, now that completes the naming of the terminals. Okay, now everything is done. Now let us go to the procedure for drain or output characteristic. So connect the circuit. Now make everything as a 0. Okay, so that would be the obviously the first step. Okay, make a value as 0 volt. Okay, we make this as also 0 volt. Okay, now run the simulation. So everything is showing 0. Stop the simulation. Now let us look at the procedure. Keep VGS equals 0 volt by varying VGG. So your VGG should be varied to set this VGS to 0. Right now it is 0. Okay, vary VDS in steps of 1 volt. So what we need to do, we need to vary this VDS by varying this VDD in steps of 1 volt. That is, we need to give 1 volt, 2 volt, 3 volt, and we need to find what's the drain current. Okay, and we need to tabulate this. Okay, and we need to tabulate this. So here so we have done VGS as 0. Now let us make VDS. Okay, VDS with some values of current. Okay, so first let us make this as 0 volt. For 0 volt, obviously the current is what, 0 itself. Okay, next for 1, let us make this as 1 volt. Now just look over here. Although you are given VDD as 1 volt, so VDS, okay, VDS is what, 0.18. okay, so what is this, 0.181 volt. So what is the current? So it is 0.819 milliamps. Next stop this, then increase this to 2 volts, then again run the circuit. So you can observe here what's your VDS, it is 0.374 volts. What is the current? It is increasing, 1.626 milliamps. Next stop this, increase this to 3 volts, click on OK, again run the circuit. Now what's your VDS? 0.580. so it is 0.580. so what is the current? So it is 2.420 milliamps. Then stop this, then again 4 volts, click on OK, then run the circuit. Note down the reading. So value is how much? 0.805. so the current is 3.195, Next, stop the simulation, uh, give it as 5 volt and check for the value. So what is the value? It is 1.054, and what is the current? 3.946. Okay, so this is the VDS voltage and this is the current which you are getting, right? So now we have made VGS as 0. For the second reading, what you need to do is you make VGS as minus 1 volt. Okay, make this first you make everything as 0. Make this as 0 volt, and now we give 1 volt over here and run the circuit. So this is showing us minus 1 volt. Okay, your VGS is set to what? You just need to give 1 volt here. Since it is reverse bias, it shows as minus 1 volt. So set VGS to minus 1 volt. And now go on increasing from here. Okay, and note down the VDS and ID. Okay, the same step. And now we start with 0. Obviously for 0 the output would be 0 itself. Next, here make this as 1 and run the circuit. So for 0.287 the current is 0.713 milliamps. Next, stop the circuit and make this as 2 volt. Okay, run the circuit. So here the value is 0.637 and the current is 1.363 milliamps. And stop this and make it 3 volts. Click on OK and run the circuit, and the value is 1.140 and the current is 1.860 milliamps. Stop this circuit. We make this as 4 volts. Click on OK, then run the circuit. So it is 2.060 and the current is 1.940 milliamps. Stop this and make this as 5 volts and click on OK and run this. So the value is for 3.020 and the current is 1.981 milliamps. Okay, so these are the two readings which you have got, right? You just observe the current over here. So for VGS equals 0 volt, so there is a large amount of current which is flowing here. For VGS equals minus 1 volt, so the current is reduced. Okay, you just look over, we compare this current with this current, so the current is reduced. Okay, because you are applying negative voltage, right? So we need to plot this. Okay, so for 0 volt the current will be maximum. Okay, for VGS equal to 0. When you apply VGS is equal to minus 1 volt, okay, VGS is equal to minus volt, what happens? The current is gradually decreased. Okay, so this is the plot. So this is a plot of what? So on the x-axis we'll be taking VDS, and on the y-axis we'll be taking the drain current ID. Okay. And now repeat the same thing. Okay. Repeat the same thing for VGS equals minus 2 volts. I have done it for 0 volts and minus 1 volt. I will repeat the same step for minus 2 volts. After getting the readings, you plot for three values of VGS. Okay, you will be plotting VDS versus ID. Okay, you will be plotting VDS versus ID for VGS equal to 0, VGS equal to minus 1, and VGS is equal to minus 2. So that would be your output characteristic. Now we will be studying the transfer characteristic. So before studying the transfer characteristic, let's just make all the voltages as 0. Let's make this as 0. Again, let us make this as 0 volt. Okay. Now run the circuit. So everything is 0. Fine. And stop the simulation. Next. So what is the step? Set VDS to 10 volts. So we need to make this VDS to 10 volts. So let us make that to 10 volts by changing this VDD 10 volt. Let us run it and see what's the output. So we have made this as 10 volts. So at 0 volt it starts conducting. So this is although this is 10 volts, the voltage which is appearing here is 3.9 volts, right? Let us increase this. Let us make this as 3. Let us make this as 30 volts. Now this is 20 volts. Instead of 30, let me make it as 15 volts. Let's make this as 20. Let's make this as 80. 17. Okay. Now your VDS is 10 volts, right? So let us enter this in the tabular column. So our VDS is 10 volts. Now vary the VGS. We need to vary the VGS in steps of 0.5 and note down the corresponding values of ID. Okay. So for VGS equals 0 volts. Okay. We need to make this VGS as 0 volt. So stop this circuit and let us make this as 0 volt. Right now it is almost 0 volt. Okay, for 0 volt, for VGS is equal to 0 volt, it is not 0 volt, this is a minus 0.9. we are getting minus 1, right? Let me make this as 0 volt and make this as 0.1. So at 0 volts, okay, at 0 volts, the current ID which you are getting here is 6.33 milliamps. 6.33 milli 6.338 milliamps. Next, let us check for minus 0.5 and make this as 0.5. So for minus 0.5, we are getting a current of around 4.452. Next we need to check for -1. Let us make this as 1 volt and this circuit. So for -1 volt, okay, for VGS of -1 volt, we are getting the current of 2.466 milliamps. Next, let's check it for -1.5. Let's check it for -1.5. -1.5. Okay. Now let us run the circuit. So for value of -1.5, the current which you are getting here is 0.0998 milliamps. So you go on changing the value of this VGG. So there will be corresponding VGS value. We plot that here, okay, and you'll be getting the current over here. Okay, just observe here, as the VGS is getting negative and negative, the current is decreasing. Okay, so you'll be plotting this in a graph. Okay, so this is your minus VGS 0, 0, minus 0.5, minus 1, minus 1.5. so this is your current. So the current is decreasing as the value is getting more and more negative. Okay, so that would be your transfer characteristic. Okay, you have learned both output characteristic and transfer characteristic of JFET, and the link for this Microsoft Word document will be available below the YouTube video. You just download this both MOSFET and JFET Microsoft Word document, and you bring the printed copy of this, and you need to simulate this in the lab and enter the values. Okay, thank you.